So for this example, we're going to find all of the roots of this polynomial, and we're going to use the rational root theorem in order to find some of the possible rational roots. So the rational root theorem asks you to create a fraction, and you're going to be writing the factors of this constant term, which is 6, over the factors of the leading coefficient here, which is a 1. So the factors of 6 are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. And the factors of 1 would be plus or minus 1. So if I take my numerator's numbers and divide by plus or minus 1, essentially these are really my factors because dividing by 1 is the exact same thing as my numerator. So in order to check a root, you can either substitute any of these numbers into the polynomial, or you can use synthetic division. Sometimes synthetic division helps you create a smaller polynomial once you find a root. For instance, let's check the following. I'm going to check -3. So my coefficients, again, 1, 2, -5, -4, and 6. So 1, 2, -5, -4, and 6. And let's see what happens when I check -3. Bring down your 1, multiply -3 times 1, which is -3, add 2 plus -3, which is -1. Multiply -3 and -1, which is +3, add -5 plus 3, which is -2. Multiply -3 times -2, which is 6, add -4 plus 6, which is 2. Multiply -3 times 2, which is -6, and when we combine 6 minus 6, we get 0. So if we get a 0 here as our remainder, that means that -3 is a root. So far I know that x equals -3 is one of our roots. And what's left now with these numbers here, these become your coefficients, and you have x to the third now. Remember, you take this and decrease it by 1, so this is x to the third, x squared minus 2x plus 2. So I could use those coefficients now to check another number. So for instance, over here, I'm going to check +3. So again, I could use these numbers here now because they're smaller. 1, -1, -2, and 2. So bring down our 1. 3 times 1 is 3. -1 plus 3 is 2. 2 times 3 is 6, and -2 plus 6 is 4, and then 4 times 3 is 12. We do not get a 0 here. So 3 is not a root. So I'm going to erase that. All right, let's check again. I'm picking one of these numbers here. Let's check 1. So 1, -1, -2, and 2. Bring down our 1. 1 times 1 is 1. -1 plus 1 is 0. 1 times 0 is 0. -2 plus 0 is -2. And 1 times -2 is -2. So when I combine here, I do get a 0. So that means 1 is a root. So x equals 1 is another one of my roots. And then again, this is the original polynomial that I was using. So I decrease the exponent by 1. So this becomes x squared plus 0x's minus 2. So if I have x squared minus 2, I can actually find the two roots of this by setting it equal to 0. Remember, if it's an x-intercept or a root, the y-coordinate's always 0. So if I add 2 to both sides, I get x squared is equal to 2. And then the opposite of squaring something is taking the square root. So I get x is equal to plus or minus the square root of 2. So those are my two roots besides the previous two that I found. So in fact, 2 of the roots are rational. X equals 1 and x equals -3. Both of those are rational numbers. And then I have 2 irrational roots, which is plus or minus the square root of 2. So these are my 4 roots.